Any other question? No? Okay, so I will review previous section about categorical variable, quantitative variable, and we will continue chapter 1, okay? So, we had individuals and variables in our data set, correct? So what was individual? Individual was object, subject, animal, whatever that we are interested in to collect their data and do research on them, correct? Or answer any questions about them. And then variable was, do you remember?
The
characteristic of those individuals, correct? We can have one variable, two variables, many variables for one individual. And then we went through all different kind of, variable, and then we recognized we have two specific kind of variables. The nature of variables can be, one can be numerical, correct? Another is categorical. So numerical has two most important kind of properties. So numerical variables should have unit of measurement, correct? And then numerical variable also we can apply arithmetic operation on them, correct? So this was numerical variable, and then categorical variable, we said categorical variable or qualitative variables, they are different groups, they have different groups or categories, and also we can show these different groups or categories with coding also. So coding doesn't make a categorical variable numerical. This is just a coding, that we are just assigning code to each category. Okay? So this was categorical quantitative variable. It's so important to know the nature of variables, because if you want to draw a graph for any variable, first of all we should know the nature of variable, what kind of nature they have. So now we are going to start talking about different way of showing each variable. The first way we are going to talk about is graph. So how we can show each variable using graph. So as soon as you recognize what kind of nature each variable has, you will understand what kind of graph you should use. So for categorical variable, we can use just two graphs. In our class, we are going to learn about pie chart and learn about bar graph or bar chart. These two are specifically for categorical variable. We cannot use these two graphs for numerical variable. Later you will understand why we cannot use, for example, pie chart for a numerical variable. So numerical variable or quantitative can be shown with two graphs. In this class we are going to learn about histogram and we are going to learn about a stem and leaf plot. These are all four graphs that we are going to learn in Stat 145. There are many other graphs, but they are more kind of complicated or advanced that you don't need to learn. These are the most important graphs that we are going to use to interpret our variables. So showing variables with graph helps us to interpret that variable. Okay, so pie chart, bar graph, just for categorical variable. Histogram, Estimately plot just for quantitative variable or numerical variable. So just memorize that. Now I'm going to go through each of these graphs step by step. We'll learn about them. And some of graph, we don't need to draw them in this class. We just need to learn how to interpret those graphs, because so obviously nowadays softwares are going to help us to draw a graph. And also it will be so difficult for us to draw on our own. It will not be, graph will not be that precise. You know, that's why. So, but this is the graph, let me tell you from now. This is the graph we should be able to draw in this class. And also this one also, we can draw these two graphs. But histogram and pie chart, no, we are not going to, you know, draw these two graphs. Okay, do you have any questions so far? So, to be able to draw a graph, first of all, we should know frequency of each category. Or if I want to talk about pie chart, I want to start with pie chart, which is kind of belongs to categorical variable. First of all, we should know frequency of each category. Frequency of each category is, for example, if we have female, male student, this is a categorical variable, correct? We have two groups, male, female, correct? So frequency says how often we have, you know, male student, how often this female will repeat in our data set. So it means how many students are in female category, how many students are in male category, okay? So either we can accept that as a count, there are 10 students in female category, there are 15 students in male category, or we can say 50% female, 50% male, or 20% female, and how many percent male? 80%, correct? So either percentage or count shows us a frequency in each category. To be able to draw a pie chart, we need to know frequency of each category. So here you see the distribution of a variable. Distribution of variable shows us and tells us how often a variable repeats. If we have a categorical variable, how many times the category is repeating. And overall, I can say it gives us information about frequencies of that variable. So this is a data set for us. But in this data set, you don't see the individuals. So as soon as you read this, you will obviously understand who are the individuals in this study. So it says field of study. These are different fields of study. So who are the individuals in this study? The students, correct? So field of study, we had already in previous section. We had all our individuals as a student and different variables, and field of study can be one of those variables. So a student of a university or college or anywhere that we don't know yet are individuals of this data set. So now field of study, these are all different groups. So you tell me, what kind of variable is that? Categorical, correct? Why? Because we have different groups, correct? So these are different categories, different groups. Art and humanity, biological science, business, and up to here, other major and undeclared. So it means there are some other major that they gathered all together in one group because they didn't have that much of a student in those field of study. Okay? And then they total means they added up all these percentages. So now what is this percentage? 10.6% of a student belongs to this category. So we have percentage of a student. Percent of a student. So this is the frequency for this category. Alright? And then for example here we have 11.2% of a student who belongs to engineering category. So this is the way we have our frequency for each category. So this doesn't show we have a numerical variable, because obviously you look at this and you will understand you have categories here. The number you see in front of each category is frequency, correct? So frequency of that category. Now, we use this frequency to draw our graph. So this is, so obviously, again, as a review, this is a categorical variable, correct? We have just two graphs per categorical variable, either pie chart or bar graph. So now I should show you either pie chart or bar graph, correct? So now, this is the bar graph you will see for that data set. So pie chart, sorry, pie chart. Pie chart, as it says, it's like a pie circle, and we have different slices. Each slice shows us a category. So in previous data set, how many categories we had 10 categories. So now we have 10 slices here. And then as you see, above each slice, we have the name of that category. So it will you will easily understand this category with this color shows physical science. And then why this is a small? If you go back to the previous data set, the smallest percent is 2.4 for physical science, correct? So now you will understand the size of each slice shows you have either a bigger frequency or a smaller frequency in that category. More number of a student or less number of a student, correct? So now if I ask you here, what is the, which field of study has the lowest number of a student? You can easily say, look at this graph and say, okay, the smallest slice is physical science. So physical science has the lowest percent of a student, correct? Without even going back. You can compare each category. And then if I ask you which field of study has the highest, you will look at this and say probably biological science and business. So that's why, look at these two, they are similar almost, correct? If you go back to the percentage, probably this would be these three, this one, biological science and other field would be the highest. 14.9% for other. And then we have 14.7, 14.5 for these two fields. So that's why they are so close together. So in this situation, in this case, what we can do, we can design our pie chart to be more specific. I mean, without wasting time and going back to the data set, we could just write down percentage inside each of these slices. So that would help us more. Or design it a different way. I mean, computer gives you lots of, choices to draw your own pie chart to make it much easier to understand and interpret. So the most important aspect of this kind of graph, pie chart, is to compare different categories to see which one is bigger, which one is smaller, which two are similar in that situation. So now there are some properties for pie chart that you should know. First of all, let's go back to this to see what happens. So all these percent of a student, these are percentage, correct? So if you add them all, the total percent of a student should add up to 100%. It should add up to 100%. Otherwise, you cannot have a pie chart. If you are missing some student, if you don't have a category, specific category, means you are missing a slice, correct? So it doesn't make sense to have a pie chart in that situation. So that's why we have to have all the data available, all the percentage, all the category to be able to draw a pie chart. Or in another word, all the percentage should add up to 100. So this is pie chart. So now what is this one? Okay, let's say that first percentage 10.6% was 10.59. And then what we did, rounded to have 10.6, correct? Then another one, let's say this one 2.38. We rounded this to have 2.4. So what happens to all these kind of numbers that we rounded up and we got rid of? So that happens here. When you add up all the categories, all the percentage, there is a small tiny error there because of those numbers. If you cut those numbers, if you round it up, or this kind of situation. So this is so tiny, it's not a big deal. As long as the whole percent is approximately 100 point something, we are good. So just remember, this is kind of error of cutting off number or rounding up numbers, okay? So now we know about pie chart. Do you have any question? Sure? Okay, so we don't have to draw a pie chart because as you see, it should be so difficult for you to be so precise and make slices perfect, so that's the reason we don't have. But you should know how to interpret that. If I give you a pie chart, you should know which category is the most frequent and which category is the less frequent, and something like that, or answer question, depend on your knowledge. The most important part is you have to add up all the numbers, all the percentage to get 100%. Otherwise, you will not have pie chart. Okay, so this pie chart, categorical variable, slices shows categories. And now, bar graph. Bar graph, this is bar graph. As you know now, bar graph belongs to categorical variable, just categorical variable. Each of these bars here represent a category for you. So, in bar graph, each bar represents a category for you. So this is the first and most important thing. Second, height of each bar shows frequency of that category. Height of each bar shows the frequency of category. Then what else? On x-axis, we have all the categories, like this way, showing the categories. So if you look at this bar, we know what kind of category is that. Okay? And then, because I said height of each bar shows the frequency, so obviously on this axis you should have frequency, correct? Either percentage or count, correct? Now, there is one thing important here, because later we will see a graph like this, and then you will say, these are similar, but I will tell you no. Because first and most important thing, in bar graph, you will see, what is the difference? Can you even see the difference between this one and this one? Just first look.
There's spaces in between the paragraph.
Correct? So those gaps. So they are apart. So why? Because categories are always separated from each other. They are not continuous. They are not connected. So first of all, gaps. So in bar graph, you always see gaps. You should always, when you want to draw a bar graph, because I said you should be able to draw a bar graph, in bar graph, you should always have gap between each bars. Always. So if you connect them, that's wrong. So always we have gaps between bars. And now another thing. Okay, let me tell you what's the difference between these two. So this was messy, this one is more organized. So it doesn't matter which categories comes first, which categories end. So you can just, because they are not connected, correct? So you can just organize them. Decreasing or increasing. Or leave it like this. Doesn't matter at all. So now let's continue to see the difference. Okay. So bar graph, I said there are gaps. This is the first and most important thing. And then for bar graph, one of these axes, as you see, is name of categories, correct? But here, if you come here, you don't see any categories, correct? So these are two most important difference between these two graphs. So as soon as you look at a graph which are similar, you should look for categories and look for gap, and then you will say that is bar graph, correct? Otherwise, that's other kind of graph. Okay, so let's go to this one, see what we have. Okay, so now, as you know, this is a bar graph for categorical variable. So we can, if you organize it, it's much easier for us. We see that these three fields of study, they have almost the same number of percent of a student, because the height is almost similar, correct? And then here is the lowest one, physical science. So it's much easier than pie chart, correct? And also there is one huge big difference between pie chart and bar graph. What is that? If pie chart, for drawing pie chart, we have to have all the categories possible. For bar chart, doesn't matter. We can just ignore one of these bars and compare just 5 of them even. You know, just keep 2 of these bars and delete the rest, because you are going to compare just 2 categories. Doesn't matter. So it doesn't matter if the percentage, it doesn't add up to 100. Doesn't matter. So this is a huge difference between pie and bar graph. For pie chart, you should have all the 100% of data. For bar graph, doesn't matter. You can just keep 2 categories and compare them. Any question? So these graphs are not difficult at all. Okay, so let me give you an example. Do you have any question? Okay, look at this. It says, display the distribution of these pits in a well-labeled bar graph. So we want to solve this question, to draw a bar graph, okay? So, how many categories we have here? 4 categories, correct? The first thing, actually we have the list of categories with their frequency. The right side column, number of pets, is frequency, correct? So we have them, but at in some question, you have to count them. If you have 5, 6, number, you should count them to see how many times a specific category repeated, that would be your frequency. How many times another category repeated, that would be a frequency. This is just a straightforward, you have it. So now we need X and Y axis like this. And then on this axis, we are going to show frequency, which is count, it's not percentage, correct? And then let's measure them. So I know it starts from 7 up to 53. Okay, so let's say 50 is here, correct? So I'm going to make it more kind of precise. and this will be almost, let's say, okay, you know what, let me separate it to 5 different, because I said 50 is here. So 1, 2, 3, 4, 5. So 40, 30, 20, 10. Good? So I just measured this axis. And then 7 will be almost here. 9 will be almost here. So before doing that, let's show the categories on the other axis. So let's say here we have, what's that name? Parakeet? Parakeet? What animal is that? Bird?
Yeah.
Small bird. I didn't know that name. Dog, cat, and then, oh, I know hamster. Okay, so we have 4 categories, correct? So now I labeled that. And what label means exactly? Here you will write down frequency and count. Here you will write down pace. So it shows these are the categories of pace, and this is the measure on this axis. Okay, so now I said we have bars, they are not connected, we have gap between each bar, correct? So keeping all those things in mind, we will have bar, and the height of bar is important for us. This bird, we have 9 of them, and you can draw an imaginary horizontal line, correct? To show that this one is 9, correct? And then for dog, we have 22, let's say here, imaginary line to show us the height of this bar. So 22. And then cat, we have 53. Let's say here. Another bar. And then the last one, we have just 7. This is the other category. So that's it. This is the way you draw a bar graph. So if you have all the frequency, it's easy. But if you don't have the frequency, you should count to see how many times, that specific category repeated. And then you will say, okay, this first category repeated this many times. This is a frequency. This second category repeated this many times. This is another frequency, correct? And you will use those to draw a graph. Do you have any question?
Do we have to put the numbers on top of each bar graph every time?
No, you don't have to. Now I just wrote them because this is the first time you are drawing this graph. So I wanted to just mention that which category we are exactly talking about.
Okay.
Yeah, we don't have to. But just be careful. There are some important thing about drawing a bar graph. You will have gap, correct? You should definitely have gaps between these categories. Second, you should write down the category's name, correct? And the third one, you should have the measure on this axis. Not so detailed, but approximate measure, correct? So these are the things you should know. Okay, so now let's go to the are you done with this? I don't think you need this anymore. Okay, so now we know about bar graph. So again, I'm going to repeat the difference between bar graph and pie chart. For pie chart, we have to have all the categories, all the percentage should add up to 100, correct? But for bar graph, no, it's not important. But both of them have the same property. What is that? Both of them are belong to categorical variable. Okay? So as soon as you see a categorical variable, if I ask you what kind of graph you can use, you will say either pie chart or bar graph. If percentage adds to 100, we can use pie chart. If it doesn't, if it adds up to 100, we can use pie chart. If it doesn't, we should use bar graph. Okay? So now this one, now we want to talk about quantitative variable, numerical variable, okay? So now, let's say this is a whole data set, everything is like perfect. Tell me, look at this, it says percent of state high school students graduating on time. So think about this and tell me, what is the individual in this study? What is that? Louder.
High school students.
No.
Graduating
The
students. Students graduating.
Student graduating, no.
Oh, the states.
States. Correct? State. Region, no. Region is a categorical variable itself. Correct? That's a characteristic of states. This one is also characteristic of states. So states are the individuals in this study, correct? And then we have two variables, region and percent of high school graduate. So, which one of these variables is categorical? It's obvious, tell me. Region, because the state was individual, correct? So region is categorical variable. If you want to draw, you can draw a pie chart or bar graph, depends on how many, if you have 100% of all the states. And then you will see, okay, how many times NE repeated, that would be a frequency for NE. How many times S repeated, that would be a frequency for S. How many times W repeated, that would be the frequency of W, okay? And then which one of this variable is numerical? What is that?
The percent.
Exactly. This one, which is percent of high school graduating. Correct? That would be numerical variable. Correct? So we are now going to use this to draw a histogram, the first one. First graph we are going to talk about for numerical variable. And I'm going to use this numerical variable, percent of high school graduation. I'm going to use this one, this column, to draw a histogram. So the first thing in histogram, you will look at the data and you will see what is the lowest percent of high school graduation. You will look at that and then find what? Huh? What is the percentage? This one, correct? 59. This is the lowest, correct? And then what is the highest? 80. Do we have 90? 88, Iowa, correct? So, first of all, we should see what is the lowest percentage, what is the highest percentage. That will consider as a range of data for us, lowest to highest. Okay? So for histogram, there are some specific kind of rules. You should always be careful about that. So we are going to divide this range we have from minimum to the maximum, divide this range to some class intervals. We call that bin, B-I-N. So they are not bars, they are class intervals. So here we have B-I-N, or we call them class intervals. So we have to divide our range to some class intervals. So if you want to divide this range to some class interval, depends on how many class intervals you want. For example, this graph shows 1, 2, 3, 4, 5, 6, 7 class intervals. So I said each of these are class intervals or bin. So depends on how many you want. We should adjust our range. You understand? So imagine the number should be multiple of this number of bins, correct? So you don't want any decimal or anything, difficult. You want something like a whole number, a perfect number. If you want to divide the range by the total number of bins. So for that reason, to be more to make everything more easier and to have all the categories, we add a little bit of number to the maximum number, and we have a little number to the subtract from the minimum number. So we adjust the range for ourselves to be able to divide this range to number of bins we want. So number of bins is 10. They said, okay, now we know the minimum is 59, the maximum is 88, correct? We can adjust our range from 55 to 90, and then in that way, we will have a perfect whole number in each bin. Just imagine, subtract 90 from 55. How much you will have? 35, correct? So the whole range will be 35. Divide the 35 by the number of bins. Each bin will be again.
5.
So 5, correct?
Yeah.
So you will have 1, 2, 3, 4, 5, 6, 7. So my mistake, I said 10, correct? That's why. We have 7 bins. Let me write down. So they started from 55, ended till 90, correct? So now our range will be from 55 to 90, correct? Subtract this number, the whole distance will be 35, correct? How many bins we have? 7 bins, correct? So now each bin is 5, correct? So now everything is like perfect. At first, if we didn't adjust this from 55 to 90, and if we just use 59 to 88, just with subtracting and dividing, you will understand the number for each bin would be really messy, correct? So that's the reason. But it depends on you, how you want to adjust your range. Maybe even with adjusting, like with adding one number to the right side and subtract one number, you can. Depends on you, how you can perfectly adjust it to have a whole number. So this is the way. That's why they started from 55 to 90. Even though our minimum is 59, our maximum is 88. So now question. Anything?
So what was the purpose of this again? Why do we do this?
To make each bin or class interval a whole number, a perfect number, rather than having decimal or anything. Why that happens? Because so if you use 59 to 88, subtract them and then divide by number of bins 7, your number would be messy. It would be like decimal or something, not 5. It wouldn't be a perfect number. That's why, that's the reason. We make it perfect in this way.
What does a 5 represent?
5 is the length or
goes up 5 each time.
yeah, width for each class interval or bin. So now I want to talk about this one. Width or class interval for each bin. So we know each class interval has 5 units, correct? We call that, we have to, for histogram, we have to have the same unit for all the class intervals. We cannot have a smaller class interval at one point and the bigger one in another point. All the purpose of doing this calculation to have a perfect number and all our class interval have the same width, correct? So this is the main and most important properties of histogram. All the width should have the same numbers, correct?
That was for like the height.
No, it's not the height. It's just the bottom part. You're right. This part.
Yeah. Okay.
Yeah. So now, as soon as I go to the histogram, I will again review everything to see what happened exactly. So now, I want to talk about this page, and then we will go ahead and review everything again, what happened exactly. So for each class interval, we will have 5 as a unit or width, correct? So starting from 55, because our range is now 55 to 90, correct? So the first class interval will be 55 to 60 because it's just 5 units, correct? And then another class interval starts exactly from 60 to 65 because now we know each class interval has just 5 width or 5 units, correct? Up to the last one, and we should have 7 of them. 7 multiplied 5 is 35, and we are covering all the range, correct? So that's the reason. Now, let's go to the graph to see what exactly this graph has. So now, these are the class intervals that I was talking about, or bin, B-I-N. So each of them has 5 units, correct? All of them have the same units, same width, correct? And then they are connected. Do you see that? In compared to the previous graph we were talking about, these are all connected. Why? Because the numbers are connected. The percentage are connected. They are all after each other, correct? So now, here, the first one is from 55 to 60. What is this? This is the percentage of high school graduation, correct? If you just review, these are the percent of high school graduation, correct? We want to see, listen to this, we want to see how many states fall in this specific class interval. What that means, we want to see how many states has percent of high school graduation from 55% to 60%, correct? Here, we want to see how many states has the percent of high school graduation from 60 to 65, and up to the last class interval. Is that clear? Sure? Okay, so now another thing. Let's say you have a state which has exactly 60% of high school graduation. So what you will do at that point? Look, 60 is a boundary between these 2 class intervals. So that state will belong to which class interval? Do you understand what I say? Do you understand my question?
It belongs to the right side.
Why?
Because on the direction there it says less than 60, so it's 50. So it's 50 to 59.
Let's go back to this one. Do you remember even last time when we were talking about data set? I always had a note. So everything should be so perfect so we know what's going on exactly. So these boundaries here, what they are talking about. The first class interval from 55 to less than 60, correct? It's not, 60 is not included in the first class interval. Do you see that? Why? Because we don't have that equal sign. If you remember your math, we had less than equal, we had greater than equal, or we had just less than. What that means less than alone means it's not included that number. It's not equal to that number, correct? So this means less than 60. If you have any like a state which has a 60% high school graduation, that belongs to the second class interval, because this one says start from 60 to 65. So everything is like perfect for you to, as a note. Now you know what exactly 60 belongs to, correct? Or if all this side doesn't have an equal sign, if one of these doesn't have equal sign, the rest should not have equal sign. You cannot just skip and say, this belongs, okay, this one I don't want that belong. No. All this side says not equal to, correct? But all this side says equal to. Correct? Do you understand what I mean?
Yes.
So this one says 70 included, 75 not included, 65 included, 70 not included. We should always keep the format that way for all the class intervals. So now if you go back to the table, you will find that there is just one state belongs to this class interval. Two states belongs to this class interval. So again, as a review, one state has a percentage of high school graduation between 55 to less than 60, correct? Here, 9 states belong to this class interval, means 9 states has a high school graduation between 85 exactly to less than 90. Do you understand this? Is that clear? We use this table as a frequency table for us. Now we know how many times the states repeated in this class interval, correct? Just one time. How many times the states repeated in this class interval? 16 times, correct? We have 16 count in this class interval, for example. So we use this to complete our histogram. Now, height of each class interval shows the frequency. So, height of each class interval shows the frequency. So obviously this one means 16 students, because this is the highest, correct? 16 students belong to this class interval. 16 states, did I say student? I said states. Oh. 16 states belong to this class interval, which has high school percent of graduation from 80 to less than 85. Just one state belongs to this class interval, which has high school graduation between 55 to less than 60. Correct? So height of each class interval shows the frequency. Do you have any question? Yes.
So do the number counts of all the states add up to 50?
It should. That's a good question. How many states we have in America? It doesn't matter, because pie chart is the only graph that tells us we have to have all 100% of observations. Here doesn't matter if they are missing one state. How many states you have here? 17 multiplied 3, correct? Yeah, we should have all of them. Just one state, we don't have the data for that state. Do you see that? Top part, third column. Correct? So we have the rest. Oh, one more here. This one also we don't have data, correct? So, yes, doesn't matter if we don't have all the states or all the information. We can build up our histogram based on the information we have. Correct? Any other question? So, you know what? There's one thing some of my students would ask me if they read the book. They will ask me, you didn't ask, you didn't read the book. Okay. So, here look at this. There are some bar graph in a book. You will see they are like rotated to other side. Like this axis goes there and that axis goes here. We should be so careful if you want to design your bar graph that way.
It'll be example.
Yeah, exactly. So the height will be like this, right? Horizontally. You can do that. especially in exams of my student, they want to make a huge graph. They don't have that much space, so they make it like that, like rotate that. So yeah, that is possible too. So if you want to rotate any graph, you should be careful. So here maybe you can put all the class intervals that side and bring all the frequency this side, and then your graph will be rotated like this, okay? Do you have any question? So this histogram has lots of details, how we can interpret the histogram, because it's the kind of most important graph we will have. So now, I will go through everything, like, not detailed, because still we will actually, I think I should, yeah, I have to explain this. So now we want to explain how to interpret the histogram. If now we learn how to draw a histogram, I mean, we are not going to draw a histogram in this class, it will be time consuming, correct? So now we are able to interpret that. How? First of all, we should look at the overall pattern. Overall pattern of histogram. We can talk about the shape of histogram. We can talk about the spread or range of histogram. So when I say a spread, let me write this down. So overall pattern of a histogram has three important parts. So for histogram, if you want to talk about overall pattern of histogram, we can talk about three things. One is the shape of histogram. Then we can talk about the spread. Then we can talk about the center. Shape, spread, and center. These are the things we can talk about if you want to interpret the histogram. So now I will explain the shape at the end. We'll talk about this. After I talk about this too, I will talk about this because you should know this in detail. Spread or variability. Variability of histogram. Or at some point you will see range. Now range, you know, from minimum to the maximum, correct? So let me talk about the spread or variability, and then I will go to center. Here just briefly, because we are not going to use this now that much. Then in later chapter 2, 3, we will talk about this more. So look, so some histogram have wider range. So the minimum to the maximum is wide, okay, on x-axis. Some other histogram, they don't have a wide range. Compare these two. So this has a narrower range, correct? This one has a wider range. Do you see there from back? Do you see this? So this one has a wider range, this one has a narrower range. Data are more variable in a wider range because they can be everywhere, correct? From minimum to the maximum. Here, data are not that variable because they have less distance to walk around, correct? So they can be just between these two, and it's shorter, smaller, narrower. So when a histogram is wider histogram means we have more variability. So write this down. A wider histogram means more variability. So a narrower histogram means, now you tell me, less variability, correct? Narrower histogram means less variability. So this is the variability and spread. One name is spread, another name is variability. Both are the same, correct? When I say variability means spread, when I say spread means variability. And these are all the range from minimum to the maximum, correct? So now center. There are two measures that helps us to find the center of histogram. One is median, another is mean. Median and mean. We are not going to talk about this in this chapter. Later in next chapter, we are going to introduce the measure of centers, mean and median. We'll talk about that there in more detail. Okay, but just now you should know center means mean and median. Correct? So now go back to this one. Shape is most important in this chapter. Shape of histogram. First, I want to explain something to you about overall pattern, and then you will understand what those shapes are on these notes. Let's say I have, so I said the width of each pin should be same, correct? I cannot have a wider or narrower. So let's say this is a histogram, correct? To find the overall pattern, we connect this middle of class intervals together and then draw a line, and this line is covering all those bins, correct? And then if you remove this, what happens? You will have something like this, a kind of curve. So this shows the overall pattern. So now this curve can have three different shapes. We will talk about these different shapes now. Do you have any questions so far? So now we are just talking about histogram now, correct? We are just talking about how to interpret a histogram. I said there's center, spread, and shape that can help us to interpret the histogram, correct? And I talked about center briefly and variability briefly, and shape you should know. So this is the way we interpret shape. If that line that covering all those class intervals look like this one, like a bell shape, like a symmetric bell shape. What symmetric means? If you cut this in middle, this one will be a mirror image of that side, correct? So this is a mirror image. This side is mirror image of that side. And this is a kind of bell shape, symmetric shape. We say this is a symmetric shape. Then here, the shape is different from previous one, correct? On right side, we have an extension. This one is extended to the right side, correct? So that's why we call this right skewed shape. And then add this in parentheses beside a right skewed shape. This is a positively skewed. Positively. Why positively? I will tell you. On histogram, all the numbers we were organizing was from minimum to the maximum, correct? And then in real line number, all the positive number going to the right side, correct? Do you understand me? All the positive number go to the right side, and then all the negative numbers go to the left side. Real number line. Do you remember? 0 is middle, right side positive, increasing, left side decreasing to negative, correct? So, if it is extending to the right side or positive side, we have positive skewness, correct? So this is another name for right skewed. Positively skewed because it's going to the positive side, correct? On a real number line. This is another shape we may have. It's extended to the left side now. This is left skew. So, what is the other name now?
Negatively.
Exactly, negatively skewness, correct? Or negatively skewed. So, we can have positive skew, from the first. We can have three shapes, correct? What is the first one you saw? Symmetric. Another one was? Right skew. Right skew means it's extended to the right side. The skewness is on the right side, correct? Left skewed is the last one, means the skewness is on the left side and it extended to the left, correct? So now I will go back to my previous histogram. What is, look at this. What is the shape of this histogram? Exactly. Left skewed because it's extending to the left side, correct? And the skewness is on the left side. This is a left skew. So if you have a graph, you can choose either of these, depend on the shape. Either symmetric, left skewed, right skewed. So these three they don't happen all together, correct? Either of these. You cannot have both right skewed and left skewed, correct? You cannot have both symmetric and right skewed, no. Either of these. So this obviously shows the skewness is on the left side, correct? And we have a left skew. Do we have any more? Oh, we don't have shape for bar graph. Write this as a huge note. No shape for the bar graph because bar graph is for categorical variable. We don't have numbers on x-axis, correct? No shape for bar graph. Remember this always. Shape is just for histogram. Okay, so the part here, we call this peak. This one is peak. We have just one peak here, correct? One peak. This one is peak. And this one is also peak. So we have just one peak in these graphs, correct? In these shapes. Do you have any question? No? Yes.
Some graphs have more than one peak.
Yes, they can. But in this class, we are not going to go through those kind of bimodal or multi-peaks graph. We just talk about unimodal or one peak. Okay? Yes, it is possible. Okay, so now I want to talk about the stem and leaf plot. Before I talk about the stem and leaf plot, I want to review bar graph and histogram and talk about the difference between these two to make everything clear for you. Then we will go to a stem and leaf plot. Okay, so bar graph for what kind of variable? Categorical. Histogram is for numerical, correct? We have gaps in bar graph, but we don't have gap for histogram, correct? On x-axis of bar graph, what you saw? Categories, correct? On x-axis of bar graph, you saw category, but on x-axis of histogram, what you saw? Range or numbers, correct? So this is a huge difference. Then what else? We don't have shape for bar graph, correct? But we have a shape for histogram. But for both of them, the height shows frequency, exactly, correct? And then we went through some interpretation of histogram, and then later also I will talk more about how to, interpret more and explain more about histogram. So now I want to start on stem and leaf plot. So a stem and leaf plot is belong to numerical variable. This one. Numerical variable, stem and leaf plot. So we should have numbers, correct? Either percent of high school at graduation, or student's grade, or what kind of other variables were numerical? Give me example of numerical variable. Age, correct? What else?
Distance.
Distance, weight, height. All of these are numerical, correct? So we can use a stem and leaf plot to draw those kind of variables, show those variables, correct? So now let's say we have some numbers here. Our numbers here are decimal. So you can just at first write down before I forget. Doesn't matter if you have decimal or not decimal, because you saw lots of numerical variables. They didn't have decimal, correct? Age doesn't have decimal if it is in years. So doesn't matter decimal or not, because I know most of my students, they are thinking about that after I review stem and leaf plot. So at first just write down in parentheses, doesn't matter decimal or not, as long as you have numerical variable, you can draw a stem and leaf plot. Okay? So the first step you will write down is to organize your data from minimum to the maximum. If you have age, if you have a student's grade, you will organize them from minimum to the maximum. Correct? Like on histogram also we had minimum and maximum, correct? On x-axis we have from minimum number to the maximum number, correct? So the first thing, organize them. You have two columns. The first column is a stem. The second column is leaf. First column, stem. Second column, leaves. To find the stem, which is the first step, so first step was organizing data from minimum to the maximum, correct? Let's say these are our data, we already organized them. Do you see that it's organized, correct? So now it's easy. Go to the first number. This is the first number, correct? 1.3. Cover the last digit on the right side. Last digit on the right side. Whatever remains for you is stem. Correct. So the first stem you have is 1. So again, cover the last digit on the right side. Cover the last digit on the right side. Whatever remains on the left side is stem. Here, cover the last digit. The stem is 2. Cover the last digit. The stem is
2.
Cover the last digit. The stem is
2.
We have many numbers that has the same stem, correct? Stem 2. Here, cover the last digit. What is the stem? 19. So that's why you will write down all the stems here. No repetitive number for stem. I know 2 was repeating many times, but you are not going to repeat that stem many times. You just write that down once. 1 is a stem, you will write it down here. 2 is a stem, you will write it down here. 3 is a stem, write it down. 19 was a stem, also write it down. All of the stem you have. So now that the number you were covering, 3 here, is leaf for this stem. So that's why front of stem 1, we have leaf 3, but we don't have anything else because we didn't have any more number that has the same stem, correct? But here too, we have many stems. What are those? 0 that we were covering, 3, we were covering 4, 9, 9. Repeated, correct? You will write down the repeated number for leaves, doesn't matter. You just cannot repeat the stem. Okay? And then you will continue. You will write down all the leaves for each stem. Question. I see some faces. Question, please. No question? Okay, so 2 important things. 0 for leaves shows we had 2.0, which is a number, correct? But if you don't have anything front of number, like this one, 15, means we don't have that number at all. So there is a difference between 0 and empty. 0 and empty leaf. 0 means we had a number, and that's a number, 2.0, but nothing here means we even didn't have that stem at all. We didn't have 17 point anything at all. Correct? So there's a difference between 0 and empty for leaves. And then 20.7 is the last. We know 27 is a stem, 1 is leaf. Correct? So we draw it like that. All the leaves. Okay, let me tell you the properties of leaf. What was that? All the number from 0 to 9 for leaves, correct? And they can repeat as many times as they are, there. So they can be repeated number there. All the numbers are between 0 and 9. 0 means we have something there. Empty leaf means we don't have any number like that at all. And then the property of a stem, we cannot repeat them. And there can be all number, 5 digits number, 6 digits number, correct? 1 digit number, doesn't matter. So now I want to show you one thing here. So do you remember I talked about shape of histogram just now? So imagine I want to rotate this stem and leaf plot. I want to rotate it to this side. Let's say stems are here, leaves are here. Correct? 1, 3 is leaf. 2, 0, 3, 4, 9, 9. What else we have? 5. So this is a kind of something like that, correct? If we continue, we have 3 and 27. We have 1 number here. And then if you draw all of these, write down all the numbers. And then if you do something like this, do you see anything here? Shape, correct? You see the shape. The most important thing, I should organize every stem from right to the left, from minimum to the maximum, to be able to show the proper shape, correct? Or in other words, I'm making that like a axis, x-axis for histogram, correct? So that's why I can have a shape. What is the shape here? Right skews, correct? So we can also show the shape for stem and leaf plot. This is the last thing I want to talk about. How long? 1 minute. So this is the last thing. Sometimes we have too many leaves for one specific stem. We have too many leaves, like some of leaves are repeating over and over and over. We have too many data. Okay, that data set in previous page was nothing. We don't have that much, but sometimes we have many. And imagine the numbers are going to be like over and over, so many numbers per leaf. In that situation, if we have too many numbers, what we can do, we can split our stems. Split the stem. Splitting a stem says, if you have a stem 15, repeat that 2 times. If you have a stem 16, repeat that 2 times. A stem 17, repeat that 2 times. In previous example, we had different stems. Repeat each of them 2 times. Okay? Front of the first 15, you will write down all the leaves from 0 to 4. 0 to 4. From the second 15, you will write down all the numbers from 5 to 9. And you are making that more neatly or more clean, correct? Instead of having a lot, too many leaves, you are organizing them. So this is the way we split our stem. So you repeat the stem 2 times. The first 15 will have all the numbers from 0 to 4. Write that down. The second stem, second 15 will have all the numbers from 5 to 9. Okay. Do you have any questions? Do this on your own, this example. It says all the number from 150 to 179. Take your homework assignment, your quiz. You should be able to answer all the questions. Now, we are done with chapter 1. Still, there are some extra stuff that I need to talk about for nursing students, for other kind of students. And those are interesting things about histogram I really want to talk about. But we are done with chapter 1. You can finish all your assignments. And then be careful, don't lose the due date, because I'm not going to extend for 1 or 2 students, no matter what excuse you have. Because already I saw lots of students, they finished it. I saw that, they got 100